Hi, and welcome to video 2 of 5 videos for section 3.7 L'Hopital's rule. In this video, we're going to be looking at indeterminate products. So in this case, we're going to have two functions that are multiplied by each other, thus the name products. And when we plug in the values for the limits, we might end up with something like infinity times infinity, or 0 times infinity. When it's in that form, we can't apply L'Hopital's rule, right? Because L'Hopital's has to be 0 over 0, or infinity over infinity. So what we're going to do is if I have the product of two functions, fg, I can rewrite this as either f over 1 over g, or if I again have and depending what the two functions are, one might be easier to move in the denominator versus the other. So here I left f in the numerator, put 1 over g in the denominator, and why can I do that? Well, let's look. If I wanted to simplify this thing using the keep, change, flip, a fraction divided by a fraction, it's what? It's f times, well, 1 over g. If I flip it, that's g over 1, so I still get f times g. So the key is, whatever function we move to the denominator, we have to change that into a reciprocal of itself, 1 over that value. That way, we still have the same thing that we ended up with, it just looks different now because of us manipulating using fractions. So this one we left f in the numerator. We can also do the same, leave g in the numerator, but now we need to put 1 over f in the denominator. Alright, so let's look at an example where this is going to need to be necessary to do. So let's say, example, we want to find the limit as x approaches 0 from the right side of x times the natural log of x. So if we have a product here, right? One function is x. So let's call that our f function. Oops. So we'll call x is our f function. And then natural log of x is our g. So f times g, two functions multiplied by each other. If I plug in 0, what do I get? Well, 0 for the first piece times natural log of x as it approaches 0 from the right side. Remember what that graph looks like. Remember I told you guys when we were doing these, it's going to be important to remember. Well, as we approach 0 from the right side, what does the function approach? Negative infinity. So we get 0 times negative infinity, which is one of these indeterminate products. So we need to move one of the pieces to the denominator. We need to rewrite this function. So sometimes it's easy to see, sometimes it's not. Sometimes you got to guess and see how does it work out for you. In this one, because my f function is just x, that's pretty easy to just change into a reciprocal instead of 1 over natural log of x, because remember, we're going to have to take the derivative of these. So if I rewrite this thing as natural log of x over 1 over x, and again, that's the key, it's 1 over this function value. So once I do that, now what do I have? I have negative infinity, and if I plug in 0 here, as this gets real small, this gets real big. So it's basically now negative infinity over infinity, which again is okay. That's our, now we can use L'Hopital's rule. So if I use L'Hopital's, I need to take the derivative of the numerator and the derivative of the denominator. Derivative of natural log of x is what? It's 1 over x. And the derivative of 1 over x, this is like what? This is equivalent to x to the minus 1 power. So if I take the derivative, I bring the exponent down, negative 1, subtract 1, so that's minus 2. So x to the minus 2, which is x squared in the denominator. So derivative of 1 over x is negative 1 over x squared. So now if I simplify this, limit as x approaches 0 from the right side, it's 1 over x times negative, so I'm going to keep change flip here, fraction divided by fraction, change it to multiplication, so times negative x squared over 1. So one of these x's cancels with one of those, so I have the limit as x approaches 0 from the right side, and all I'm left with is negative x. So now when I plug in 0, I get what is an answer? I get 0. So the limit of the product, x times natural log of x, as x approaches 0 from the right side, is just equal to 0. So that's it. The main thing here, taking one of the functions, turning it into a reciprocal, moving it to the denominator, then we're able to apply L'Hopital's rule. So I only did one example in this video, and in video 5 where I work some more examples, I do another one of these types, so if you need more help, you can go to that video. But for now, that's the end of video 2. Come on back and we'll look at another form that we can use L'Hopital's rule on.